So here we are, still drawing Lewis electron dot structures, and we're going to look at some special situations in the next few videos. The first one is, what do you do if more than one structure is possible? Well, the first thing that you do is you assign what are called formal charges. Formal charges. And you can calculate formal charges for every atom inside of a Lewis electron dot structure. And the atoms that end up having the formal charges closest to zero's structure is usually the most dominant. So here's how to calculate formal charge. Formal charge is calculated by taking the number of valence electrons in an atom on the periodic table. Like, for example, let's say it was fluorine. Well, 7 electrons would be assigned to that, so you put a 7 here, minus the number of electrons assigned in a Lewis dot structure for that atom. Now, bonds only count as 1 electron per atom, so be careful when you're adding this up. If it's an unshared pair, you count 2 electrons. If it's just a dash, a bond, then remember you assign only 1 electron for that. You'll see in an example in a little bit. So let's look at carbon dioxide. You can find this information, by the way. I had the book out here on page 356 of the digital book of Brown-LeMay-Burston 13th edition. Let's take a look at carbon dioxide. Now, carbon dioxide, we're going to go ahead and draw the Lewis electron dot structure for it. And if you sum the valence electrons, you get 4 plus 6 plus 6, or 16. Then when you're drawing the Lewis electron dot structure, you take the least electron negative atom, put it in the middle, and bond the oxygens around it. You go ahead and add them up, and you find out that the Lewis electron dot structure is not going to work, so you have to use double bonds or triple bonds. So let's try a double bond here, and let's try a double bond here that uses up 2, 4, 6, 8 electrons. 16 minus 8 leaves us with 8 electrons remaining. So 2, 4, 6, 8. We have an octet here, we have an octet here, we have an octet here. That's a possible structure. Now somebody's jumping up and down and said, yeah, but you just jumped to those double bonds. Why couldn't we have done this? Maybe we could have done a double bond here and another bond here. And we could have had 2, 4, 6, 8 used right here. 8 electrons left. 2, 4, 6, 8. Octet here, octet here, octet here. And you're right. There's 2 possible ways to draw it. So which one's the most dominant? Not saying that either is completely wrong, but which one's the most dominant? Well, assign formal charge for each one of the atoms in here, and the ones that are the closest to 0 would be your structure that is probably the most dominant. So let's go through and assign and calculate formal charge for each one of these. First of all, find the valence electrons assigned on the periodic table for oxygen. Oxygen is group 16, so there's 6 valence electrons assigned to that. So 6 minus the number assigned here, 2, 4, 5, 6. Remember, only 1 electron per bond. Like 1 electron goes here, 1 electron goes here, 1 electron goes here, 1 goes here. So 1, 2, 3, 4, 5, 6. 6 minus 6, 0 formal charge here. All right, for the carbon, there are 4 assigned to carbon on the periodic table because it's in group 14. So 4 minus 1, 2, 3, 4. 4 minus 4 is equal to 0. 0 formal charge here. All right, how about over here? 1, 2, 3, 4, 5, 6. We know that there's 6 assigned on the periodic table already, so 6 minus 6, 0. This structure's looking good. But what about this one? All right. How many assigned to this oxygen? Well, there's 6 on the periodic table, so 6 minus 1, 2, 3, 4, 5, 6, 7. 6 minus 7, we'd have a negative 1 formal charge here. For carbon, though, there's 4 assigned it on the periodic table, so 4 minus 1, 2, 3, 4. 4 minus 4 is 0. Well, that's good. And then this one right here, 6 assigned to it on the periodic table, so 6 minus 1, 2, 3, 4, 5. Remember, only 1 from each bond, so 6 minus 5, positive 1. All right, once you've assigned the formal charges for each one of the atoms in there, look and see who's got the most formal charges closest to 0. Well, this one there's no question. Obviously, this guy right here is going to be our most dominant structure because it has the most formal charges closest to 0. So let's take a look at a second example problem. Oh, let's write this down first because you may have heard me say it, but you never actually wrote it down. So the most dominant Lewis structure generally has the one with formal charges closest to 0, just like this guy right here. And then rule number 2, if there are negative charges that reside in the formal charges, please make sure those are in the most electronegative atom, and then that possibly could be the most dominant one. Rule number 1 is the one that you really have to deal with and the one that you see show up the most. So those are the rules for assigning formal charges. And one example, I'm going to do one more example in the time that I have on this video. And this one is sample exercise 8.9 from the textbook. And it has the molecule NCS. And this has 3 possible structures, it tells us. Please draw all 3. And then once we draw all 3 of those structures, then let's please assign formal charges to find out which is the most dominant. So I'll go through the process right here for the first one, and then after that I'll probably go a little bit quicker. But first of all, add them up in the periodic table. Nitrogen is 5 because nitrogen right here is in group 15, 5. And then carbon is 4 because carbon is in group 14, so 4. Sulfur is 6 because it's in group 16, so it has 6. And then there's one more because it has a charge right up here as an anion of -1. So 10 plus 5 is 15, 16 for a total number of electrons. Okay? Then let's just assume this is written in the correct order. So let's go N bonded to C bonded to S. We've used up 2 4 electrons, so 16 minus 4 means that there's 12 electrons left. If we did 2, 4, 6, 8, 10, 12, we'd end up with not enough electrons around sulfur right there. So let's try a double bond right here. That uses 2 more electrons up, and so I'm down to 10. So now if I want 2, 4, 6, 8, 10, 12, I still don't have enough, so let's use 2 more electrons up right here and put a triple bond right here. Now with 8 electrons left, I can go 2, 4, 6, 8. Put it in brackets right here, put a little -1 on the outside. That's one possible way to draw it. Let's go back to where we were before, and let's do it this way. N, C, S, and this time, let's go a double bond here and a double bond here. 2, 4, 6, 8. I have 16 total, so I have 8 remaining. 2, 4, 6, 8. Brackets, -1 on the outside. Another possibility. You probably see the third possibility already. N, C, S right here. Triple bond on this side this time. 2, 4, 6, 8. Brackets, -1 on the outside. 3 possibilities. Which is the best? Well, let's assign formal charges. So the rules for assigning formal charges, remember, is to find the difference between the number on the periodic table. Nitrogen would be 5. Minus the number assigned on the Lewis dot structure. So 2, 4, 6, 1 from a bond, 7. 5 minus 7 is -2. Carbon, 4 minus 1, 2, 3, 4. 1 from each bond, so that would be 0. Sulfur, 6 assigned to it on the periodic table, minus 1, 2, 3, 4, 5. 6 minus 5 is 1. So -2, 0, and 1 in this structure. So we have close to 0 on some things, but not all zeros. All right, over here. Nitrogen, 5 assigned it on the periodic table, minus 2, 4, 5, 6. 5 minus 6 is -1 on the nitrogen. Carbon, 1, 2, 3, 4. 4 assigned it on the periodic table. 4 minus 4 equals 0 for carbon. And then sulfur, 6 assigned it on the periodic table, so 6 minus 1, 2, 3, 4, 5, 6. 6 minus 6 is equal to 0. It's a little bit better. 2 zeros and a -1 residing on a pretty electronegative atom. Let's look over here at this one. Starting from this side, nitrogen, 5 assigned it on the periodic table, minus 1, 2, 3, 4, 5. 5 minus 5 is 0. Carbon, 4 minus 4 again, 0. Right? Carbon, 4. And sulfur, sulfur is 6 assigned to it on the periodic table, minus 1, 2, 3, 4, 5, 6, 7. 6 minus 7 is equal to negative 1. All right, here's our choices. Well, I can see which one to rule out right away. This one's got 2 things that are not close to 0. These both have 2 zeros. And then remember the second rule. If a negative charge resides, put it on the most electronegative atom. So here I've got nitrogen to choose from or sulfur to choose from. Remember, electronegativity increases up and to the right. And so here's sulfur, here's nitrogen. It turns out nitrogen is the more electronegative atom because it's further up the chart. Ends up being 3.0 versus sulfur, which is about 2.5. And so my little bit better structure would be this one, although it could have a little debate between here. That is formal charge, ladies and gentlemen. Good luck with your practicing Lewis electron dot structures and assigning formal charges.